Imagine your data, AI data to be exact. Data comprised of billions of pulses of light that travel over and across the internet, carrying information derived from intelligence that is critical to your business. If your business relies on real-time data delivery arriving at a second's notice without quick crash or system failure, Supermicro is the clear choice. Delivering extreme performance with petascale all-flash NVMe storage to support proven architectures for AI and ML workloads, with leading software-defined storage platforms. If you're an enterprise business, government agency, or in the education and research sector building a public cloud, private cloud, or generative AI supercluster, there's only one choice. And that choice can only be exactly the best.
Hello and welcome to this session of the Supermicro Open Storage Summit on Hyperscale AI, Secure Data Services for CSPs. I'm Rob Strechay, Managing Director with theCUBE Research and your moderator for this special session. Cloud service providers, or CSPs, face intense and competitive landscape with over 5,000 providers worldwide. These range from established telecommunications companies to startups focused on specific use cases such as artificial intelligence or AI. To succeed, CSPs must ensure that their offerings align with their market demand. The need to understand their target market's needs and pain points is crucial. This is crucial for developing services that are not only innovative but also practical and in demand in their area. CSPs must differentiate their services from competitors. This can be achieved through unique features such as superior performance or exceptional customer service. Effective cost management is crucial for CSPs. Selecting vendors that provide differentiated, cost-effective solutions is critical. CSPs must continually evaluate their cost structures to maintain competitive pricing while ensuring profitability. For CSPs, introducing new services presents unique challenges. Services like high-performance computing and AI have different parameters and cost structures compared to traditional offerings like virtual machines or disaster recovery. CSPs need to adapt their infrastructure and sales strategies accordingly. Selling AI services differs from selling traditional cloud services. AI often involves fewer but more resource-intensive customers. CSPs must keep their infrastructure as busy as possible to maximize their revenue. This involves balancing the demand for various services and ensuring efficient resource allocation. Building out a robust infrastructure for AI is complex. CSPs need to invest in scalable and flexible storage solutions to support the demands of AI workloads. CSPs can benefit from the experiences of other providers. Emulating innovative approaches from successful CSPs can accelerate growth and enhance service offerings. Sustainability is becoming not just a differentiator, but a requirement as well. CSPs operate in a highly competitive market that demands continuous innovation and differentiation. CSPs navigate the challenges and seize the opportunities in the dynamic industry by focusing on product market fit, cost management, adapting to the new services, optimizing resources, and learning from others. Now, before we jump into the discussion, we would like to let you know how this day is going to roll. First off, all the materials you're going to see from all of the partners up here on stage are going to be on that link that you registered on the website, thecube.net. Also, the speakers will be live on X using the hashtag SupermicroStorage2024, all as one word, to ask questions. Now, let me introduce our speakers. First is Ben Lee, Director of Solution Management, Supermicro. Then we have Neeloy Bhattacharyya, who's the Director of AI HPC Solutions at Vast Data. Then we have Sachin Hindupur, who's the Global Strategy Leader, AMD. And Bill Panos, who's the Product Marketing Manager for Solidigm. Great to have you all on board. Thanks for joining us. So Ben, I'm going to pitch it to you first because I think I want to get a feeling from a Supermicro perspective around the whole solution and what you have going for CSPs.
All right, thank you, Rob. First of all, I'm super happy to be part of this section with our partner VAST, AMD and Solidigm. So today we will explore Supermicro in cooperation with these industrial leaders to transform storage solution for cloud service providers. So for CSP market, our solution begins with air-cooled AGPU systems. The system is optimized for environment where air-cool is really preferred. The system provides robust performance and efficient thermal management, ideal for intensive computational GPU workload and really forming the foundation for the large AI clusters. And then, based on that foundation, we now offer a 4U liquid-cooled HGS AGU systems. The system leverages our advanced liquid cooling technologies to handle the high thermal throughput for the modern GPU. It's not only improve energy efficiency, but also ensure consistent performance under heavy workloads. So the system is perfect for CSP looking for maximize the performance while minimize the cooling cost. And lastly, the Supermicro all-flash servers, paired with vast data solutions, deliver exceptional storage performance, which is also very crucial for CSP, and we will talk about that later today. So before that, I want to spend some time explain why we believe liquid cooling technology is very important to us. Liquid cooling technology is essential for next generation data center as the need for high performance computing grows. We all know GPU and CPU, they are becoming very power hungry. So liquid cooling keeps these things efficient and sustainable. So the market is really booming. We expect it's jump from $2 billion in 2022 to $12 billion in next 10 years. So Supermicro is the market leader in advanced liquid cooling technologies. Our solution include direct-to-chip cooling and the CDU with a smart management software. This innovation reduces electricity costs by up to 92%, and also delivers substantial improvements in overall data center electricity costs, noise reduction, and space saving. So most importantly, our solution already in mass production, which means our solution has been approved and adopted by Tier 1 customers. So this is demonstrate our leadership in this space. So Supermicro DLC technology is the cornerstone of our green computing initiative. And DLC can be essentially free. This really enables CSPs to reduce operation costs and energy costs, I would say very significantly. So lastly, as we continue to expand our total solution along with our GPU and liquid cooling technologies, it's important to highlight some strategic partnership that enables us to deliver comprehensive and cutting-edge solutions. And one such critical partnership with Vast Data. We introduced the Vast Data eBus in March this year based on Supermicro all-flash platform. The Vast Data eBus simplify and accelerate AI and the data pipelines, combining Vast DASC architecture to ensure efficient data access and processing. So powered by AMD EPYC 48 cores processor and the Solidigm high-performance NAND and the storage class memory, the eBus delivers exceptional storage performance with low latency and high throughput. This collaboration enables CSP to meet the demanding storage need of the AI workloads.
Yeah, and I think that to me is one of the big things for CSPs because again, they're trying to figure out how their traditional infrastructure has been built out, and this is a very different pattern. So let's bring Neeloy into this and help us understand a little bit deeper into what Vast is doing with these CSPs.
Yeah, no, thank you so much. And I want to call back to some points that both you and Ben made earlier. From our experience with CSPs, they're focused on 3 areas: relevance, brand, and cost, right? And so when it comes to relevance, a lot of the workload, especially the AI workload that the CSPs have been encountering to date, have been centered around very large GPU infrastructures and model training, right? That's been the primary workload. And while there's an entire group of boutique AI-focused CSPs that have emerged from that, at the end of the day, the margin profiles that come with bare metal GPU as a service are just candidly not that great, right? So our CSP customers have really been looking at how can I be responsive to both the broader needs of my model trainers, as well as enterprise customers start to actually deploy and serve from these models, how can I help them as well, right? And so that's where the VAST Data Platform has been extremely appealing, both on the data preparation side, with some of our ability to accelerate workloads like Spark, and then on the inference side, which needs a lot of distributed capacity and access to models and vector databases at many different locations to modulate the latency of the workload. When it comes to brand and reputation, uptime is key. And so one of the big things that VAST has been able to provide is an always-on solution, right? So you never have to arrange for any downtime. And in addition, especially when it comes to enterprise customers who are conscious about security, who are conscious about compliance auditing and traceability of what data went into what model and was used to generate what result, it's another area where we've been partnering really closely with the CSPs to ensure that they can provide a really leading edge offering to their customers. And then lastly, you mentioned margin. Margin is obviously top of mind, and all of us have been very focused on margin and helping customers. Ben mentioned a lot around the liquid cooling and making not just the GPU environment, but the entire data center more efficient. Being able to provide these services, typically these services, especially around data preparation and inference, are actually a lot more lucrative for the CSPs, right? So if we, as a group of companies, can provide a set of systems that are not only performant, extremely efficient for operating, but then provide services that CSPs can offer for higher margins, then I think we're providing a really winning formula to a lot of these CSP customers of ours.
Yeah, and I think that is the key, is when you look at the CSPs, they're always trying to understand how they can make more margin, increase their margins, while also, looking at how they can lower their operating costs at the same time. And Sachin, let me throw it to you now. I think from AMD, and if you use the word chiplet, you get double points because we love that word. So
Absolutely. I mean, AMD's Genoa line of processor chiplet based, as we all know. But getting to the point over here in terms of how AMD is very well suited to meet the storage server customer needs. So first of all, what are some of the storage servers customer needs? So first, you need to have a high performance per watt. And we talked about in the panel over here how important is the energy consumption which is taking place. But just to throw some data points, in the US, data centers are accounting for essentially around 3% of the mix currently, but they are supposed to grow to 8% within the next 5 years. And that's substantial. This is from Goldman Sachs. And for generative AI, it's supposed to grow at 70% CAGR in terms of power consumption. So that's some data point in terms of how important it is in terms of keeping it energy efficient. So that's very critical for storage server needs. Second is, you need to have high server density. Space is an important lever in terms of the total cost of ownership. So high server density, squeezing more compute is extremely important. And this becomes extremely important, especially if you look at the number of orders of magnitude for generative AI. It's supposed to grow at roughly around 100x in the next 4 years. To put it in context with the Moore's law, it's roughly around 2.25 times in the next 4 years. So huge growth in compute which is needed, and definitely that's one of the needs. Then if you look at IOPS, and that's an extremely important metric, and it's not just IOPS, but IOPS per watt, because input-output operations per second per watt is extremely important, because that input-output operations is the output, but how much is the energy being consumed for that? So IOPS per watt is extremely important. And then finally, bandwidth and latency are also important to round it up. So all this flows into what we call it as total cost of ownership. So how does AMD help? That's what we're going to get at. So there are three-pronged levers. One is the CPU, the software, and the support. So from a CPU point of view, essentially these are 5 nanometer nodes. So you are able to squeeze more compute in a unit area compared to higher nanometer nodes like 7 nanometer and above. So that's one aspect to it. So you're able to have more number of cores. In the case of Genoa family of processors, you can have up to 96 cores. In the case of Bergamo, which is also part of that family, you have up to 128 cores. So you can squeeze more compute per server and also per rack. In addition to that, you also have high core performance. And we see that through the architectural differences that we have over here. So one is, for example, you have a higher ability to higher cache size over here. So for example, you have 384 megabytes of L3 cache. L2, that's per socket. L2 cache can go up to 12 MB for L2 cache. And that is extremely important because as we know that data movement consumes a lot of power. So to put in context, if it takes 1x of power consumed to read from, let's say, L1 and registers, it can take about 3 to 10x from L2 and L3 cache, and it can take around 50 to 100x from RAM, and it can take around 1000x for storage. So that's really important. To having a high cache size will essentially minimize the number of trips to RAM and storage. And if you look at 3D V-cache technology, it can go all the way to 1152 MB. So really huge, and cache size will essentially lead to better energy efficiency and performance. And not just that, but we also have better branch predictions. You have execution engines, which are much better. And all this translates to an IPC of close to 14% improvement over the previous generation of Milan. So just one generation is a huge improvement in terms of performance. And we also talked about the wattage as well. And this is confirmed through consortium benchmarks, which we have. There are several consortium benchmarks. So for example, for storage, you could have the TPCE or analytics TPCH, AI could be TPCX AI, and several such benchmarks, just giving you a few names over here, which basically talk about an unbiased view of high performance per watt and high performance for AMD. Now, performance is not just important, but it's also, if you look at the memory, that's extremely important. High bandwidth is one of the key criteria that I mentioned. So in terms of the bandwidth, we have essentially 12-channel DDR5, and that can be 4,800 megatransfers per second. That translates to 460 gigabytes a second. Now, this is to put in context with the previous generation. It is 2.25 times more than the previous generation, which was Milan. So huge jump in the bandwidth performance. And bandwidth is also important in all of the factors which I just mentioned of the storage customer needs. Then if we go to essentially then the I/O, a PCI Gen 5. So PCI Gen 5 essentially is significantly improvised over here. So you have 128 lanes for 1P, and it can go 160 lanes for 2P. And essentially, you can also have 64 lanes of it, which can be for CXL as such. So we can have memory expansion and bandwidth with CXL, and with 1.1, and memory pooling with CXL 2.0, and that leads to low TCO as well for the customers. Now, it's important to note in terms of PCI Gen 5, how that it's 32 gigabits a second per lane. And that's a 78% improvement over the previous generation. So that's a huge improvement, and that again adds to all the points that I mentioned in terms of storage customer needs, like high IOPS, high bandwidth latency. All of that translates into that. This is one of the levers. And then when it comes to data, security is extremely important. So we have various security at AMD. So you have, for example, secure memory encryption. You have encryption in transit for CXL. And also you have Infinity Guard, which is there all the way from silicon to application. It provides protection all the way from silicon to application. So that's really important. So that's the CPU part of it. Now, CPU is one aspect to it, but there's also software, which is important. And making use of open source libraries without making changes and running it on AMD processors will essentially speed up total cost of ownership, because you have less amount of work to redo the work. So if you look at it, I gave some few examples. If you have SBTK, that's for storage performance development kit. And in this case, you have libraries like, for example, logging, NVMe or Fabric protocols. You can also have libraries which essentially abstracts the physical drives from the file systems. So all that works out of the box, so to say. The same thing for intelligent storage acceleration libraries. So in this case, you have encryption, decryption, compression, decompression, secure hash algorithms, erasure coding. So all of those work out of the box, and there's no changes to be done, and you just use it in the application as it is, and it runs perfectly well on the AMD CPUs. But in addition to that, I also gave example of optimized libraries. So we have AMD optimized CPU libraries. So these are like BLAS, basic linear algebra. It could be fast Fourier transforms, random number generations. So these are some of the other libraries where it's optimized. So because these are open source, it may not be very performant, so there could be nested ifs, there could be multiple do loops, and so on. So optimizing it really helps to improve the performance, and then again translates to meeting the needs of the customers as well, which I already talked about. So next comes to the support. Support is extremely critical, and we all know that, especially like take for example a data center or a cloud service provider. downtime can cost money for them. So keeping the server's uptime high is extremely important. Otherwise, it leads to revenue leakage. So in this case, you have various kinds of support. So you can have, for example, engineering support. You can have field application engineers. You can have also customer-related support. And more importantly, you have support for the products, depending on the product which is there. It can be all the way from 5 to 10 years. So it's very well suited, in summary, to meet the needs of the storage customers.
Yeah, and I think that's the key, is that when you look at it, and I think you mentioned it, it was that helping the CSPs understand sustainability, be more efficient, and the longevity of that system so that they can, sweat the asset quite well.
Exactly.
I think you also brought up CXL, which we'll talk about in a future actual segment, which will deep dive, I'm sure, into the bits and bytes. But I think that's a good segue to really bring Bill back into this. And why don't you give us an idea from a Solidigm perspective, from a CSP perspective as well, what's going on, what you got going?
Well, thanks, Rob. Thanks for having me today. Yeah, I want to talk a little bit about Solidigm and how we're kind of looking at the CSP needs, right? Specifically, Neeloy kind of touched upon it when he talked about elements of data collection or training or inference, and the type of workloads that are happening during those particular stages. You need to kind of focus on the product and not just strictly on pure throughput or latency, but really tailoring it to the application. And so there's various metrics that we do to kind of sort of vet that out, right? A couple of things I want to share and talk about are tests that are done. And I want to use an example of a real-world test on a particular product, the 5520, which is our TLC Gen 4 PCI-based product. And as I talk about this, I want you to also expand this to our other products as well. This isn't just like a one-trick pony, but we apply this to our full gamut of products in our portfolio. The first thing I want to talk about is let's touch upon the incredible workloads that are happening, and specifically the constant reads and writes that are happening maybe to a particular product, right? The SSD doesn't just simply receive writes at one time and that's it, or reads at one time and that's it, right? It's very complex, and they're even getting more and more complex, right? You can fashion up certain tests that would actually help elucidate to how well your product responds to these complex workloads. So the first thing I want to kind of focus on is the graph on the left, right? Which is really showcasing kind of that write bandwidth that we're applying to the drive. And at the same time, we're querying the drive for reads from the host, right? And so what we're measuring on the y-axis is we're measuring quality of service and latency measured in microseconds against the x-axis, which is write bandwidth, which is happening on the drive. And so what you really want to see is how well does your product, your SSD product, stage those writes against those read priorities. How well is that firmware working with the ASIC and working with the NAND to stage that up, right? So your latency is as low as possible. Now, under a typical application where you keep pressing the drive for more and more writes, right? You see that the bandwidth go up, you'll see that latency start to rise. And we want to see that rise maybe in a linear fashion. We don't want to see an exponential rise in latency or something even worse. So a good SSD product will show a nice linear or fairly flat, right? As you keep pressing it with more and more writes, and then you have those read requests happening. And you can kind of see our Solidigm product does very, very well against competitor products in keeping that latency as low as possible with that high write bandwidth happening. And so that's a very good test metric. We call it, a bandwidth pressure test, if you will. And in this case, we have storage review data that we're kind of sharing with you here. But you can apply this to a lot of our products, and you can do these measurements. The other thing I want to kind of talk about is another test, too. We call it a noisy neighbor test. And I think Ben kind of touched upon multi-tenancy, right? And the necessary use of multi-tenancy and multi-tenants that could be using the same pool of data. And what that could mean in terms of the overall performance of the SSD product. With NVMe products, they're set up very well for multi-tenancy use, right? We can stage these tenants within specific namespaces, right? As opposed to maybe old SAS legacy partitioning techniques that have been done, right? And it sets it up very well. We can isolate those tenants and namespaces. We can isolate them namespace locking through Opal and other techniques for security we kind of touched upon, right? But when we do that, we want to go ahead and see, is there any contamination? Is there any grab of resources from one tenant that may take the lion's share versus another? How well does the SSD manage those tenants when they may be trying to acquiesce data from the drive concurrently, right? And so this is a really interesting test for that. So what we're measuring is we've got 6 tenants, we've got 6 namespaces, and what we're doing is we're driving 3 of those tenants with writes down to the drive. So, right, so it's requesting data being sent down to the drive, and at the same time, with the other 3 tenants, there's read requests kind of coming out. So what we're trying to see is the interplay of how they're able to manage that pool of data, or we're necessarily writing to one particular set of tenants and then we're reading off those others. So we have 3 rows here. The top row is we're basically instantiating 4K reads requested from the host on those 3 tenants. In the middle row, it's 8K reads that are happening, and then in the bottom row is 16K reads. And then what you're noticing on the y-axis, or excuse me, on the x-axis, is the latency that we're seeing. And that's really what you want to measure. You want to measure how long is it taking to get those responses under that concatenate, write request to those tenants. And you can see we do a fairly good job, regardless of the transfer size, that we're sending down to the drive in this mixed write workload. The read responses are pretty low against some of our other competitor products, right? So kind of the takeaway in all this, and again, this is 2 examples. I can talk about many, many more examples if we had more time of where we're actually doing application type tests to ensure that we're optimizing the SSD product for SSD, for CSPs or other customers, right? So you basically have to kind of apply this not only in one particular area or product, but in an array of products, because as we find out, no one SSD product fits all, right? So we kind of take this as a holistic approach across all of our products to necessarily try to tune the SSD for the application.
Yeah, and I think that's the key, is when you start to look at it from front to back, the service providers are looking at how do they maximize this asset, and it may actually switch the nature of what they're using it for over time. And also, funny enough, when people put their data there, they may want to use their data for another purpose as well, or have multiple different AI solutions on top of it. So let's kind of bring it back a little bit, and Ben, I got a question for you. And what do you foresee as the biggest challenge for CSPs in the future, particularly in terms of managing the increasing demands of AI and high-performance computing workloads?
Yeah, I think the 3 main areas, I think is scalability, efficiency, and future-proofing their infrastructure will meet the growing demand about AI and high-performance computing, just like you mentioned. So I think in Supermicro, we always try to advance our offering more than what customers need now, right? So in second half year, we're going to launch the next gen, latest and greatest GPU solutions, right? And on top of that, all the GPU solution will be liquid cooling ready, because we want to make sure our advanced liquid cooling solution will capable to cool these kind of next gen GPU solutions as well. And most importantly, we also focus on advance our in-rack CDU capabilities, right? We want to have our CDU to be able to cool all the GPU solutions in the rack. So we're going to double that capacities up to like 200 kW. So it's going to be amazing solutions in coming years. And lastly, of course, we'll continue to work with the partners here to continue enhance our features in the storage solutions, right? We look for some technology innovation, collaborations to enhance the feature and also capacities, right? So I think it will be a really great journey for second half this year. It will be fun.
Yeah, no, I think again, it's when we look out into the future, that's so critical. I think you hit those bullet points, from a perspective of, efficiency, security, and really, future-proofing, and performance is in there as well. And
Yep.
I think this actually ties very well. Neeloy, I think everybody on the stage has really, benefited and really prospered in the AI service provider focused arena. What is unique about VAST's offering for this segment in particular?
So I think it's a couple things. First of all, we start with a real focus on enabling the service providers to offer multiple offerings, right? It's not just an NFS mount, it's not just an S3 bucket. It's really being able to offer many different service offerings which enables them to meet AI customer demands. But I think the other big thing is the time to value that all of us bring to these service providers, right? Which enables them to bring it to their customers. All of us on this stage are collaborating with each other on true end user consumable solutions, right? Model training, inference. You heard a lot of the great capabilities that everybody on stage has, but I think the thing that differentiates us as a group is we really work together to bring usable, consumable solutions to service providers so they in turn can offer improved time to value for their customers, right? It's because at the end of the day, and I think many people said it, the workloads are changing dramatically. AI fills every possible pipe. You talk about PCIe Gen 4 to Gen 5, it's incredible, and now Gen 6 emerging. It's incredible how it doesn't matter how much bandwidth or how much headroom you think you have, the AI workloads will absolutely consume every single ounce of it. So the fact that we can collaborate together, optimize our solutions, and really enable customers to, our service provider customers, to offer more capability to their customers faster is what differentiates, I think, us as a group.
Yeah, I like how you put it. It's, time to value is everything for service providers, and having a solution that they know they can go and implement and turn on and be able to, quickly get to revenue is so key.
Exactly.
But Sachin, how does AMD meet a service provider customer's storage service needs?
Yeah, sure. If you look at service providers like AWS, GCP, the top CSPs as such, which are there, and others as well. So the key things is what do they need? What are their top needs? There are various needs. What are their top needs? One is, of course, TCO. You need to have low TCO. You need to have essentially high performance per watt, and that's extremely critical. And meet the energy efficiency, so high energy efficiency, and meet the sustainability goals. So this is extremely important as well. And all that, like as I mentioned, it should be at a low TCO. So, and more importantly, CSPs have wide variety of customers, from small and medium business all the way to large enterprise. They have wide variety of workloads. So it needs to support all these types of workloads. So let me take you through all the different types of workloads and how AMD can meet all of these goals, the needs of the CSPs as such. So if you look at the types of some of the top workloads, and that accounts for close to 80-90% of the workloads as defined by IDC. So if we start with general purpose, so this is like essentially ERP, SCM, it could be data management, analytics. So essentially in this case, you have the Genoa family of processors, which is up to 96 cores. It can be up to around 384 megabytes of L3 cache. So high cache size is extremely important, as we talked about. It also has frequencies which can range on to 4 gigahertz and above. And essentially, it has very high socket performance and high core performance. That's a key thing, and high energy efficiency. And this is validated through consortium benchmarks, like I mentioned. So to put some perspective on this, you have TPC-E for structured databases. You could have TPC-X for analytics, AI analytics, or it could be TPC-H as well for business intelligence. So there are various benchmarks which validate it, so unbiased view as such. Then if we go to the next kind of workloads, this is high performance compute, technical computes. So this would be workloads like CAD, CAM, CAE, computational fluid dynamics, simulation. And in this case, you need high compute. And essentially, you have the Genoa X line of processors. Over here, you have essentially up to 96 cores for this. And it has a 3D V-cache technology, which is up to around 1152 MB of L3 cache. And that's a huge cache, essentially makes a boost to the performance and the energy efficiency. So this is extremely critical as well. You have, again, third-party consortium benchmarks, as I mentioned. So in this case, you could have ANSYS Fluent. You could have Spec HPC. These are benchmarks which essentially validate the high performance and high energy efficiency. And if we go to the next workload, essentially if you have infrastructure workloads. So this is for virtualization and cloud native workloads. And in this case, you have the Bergamo line of processors, which can be up to 128 cores. And essentially it provides the highest density, high energy efficiency, and highest performance. And you have, for example, for VMmark, VMmark is essentially a consortium benchmark, and essentially is, again, provides an unbiased view of this statements which I just made. And then you can also have telco and edge cloud. In this case, essentially you have, there are constraints which are very unique for this particular workload, which is space and power constraints. So this is at the edge as such, or the telco towers. So in this case, you have the CNL line of processors, in which case you have essentially up to 64 cores. It could be 6-channel DDR5, but more importantly, it operates in a very small thermal envelope of 70 watts TDP. So it's very well suited for these types of workloads. So all in all, as you can see in summary, AMD has a vast family of processors essentially helping meet the needs of the CSP customers.
Yeah, and I think that's key because, like you said, not one size fits all.
Exactly.
And not one workload is what they're doing in these locations. They got to keep these busy for the most part. So, Bill, from a Solidigm perspective, how is Solidigm helping its customers, CSPs and others, really get the most out of their AI-based solutions?
Yeah, thanks. Well, one of the things that Solidigm has, and we've been working on NAND for quite a while. We're on our 5th generation of NAND, right? Is just our wide portfolio. We talked a little bit about the staging within AI, whether it's the data collection, the training, the inference. We offer a wide array, right? Including our SLC products up front can be used as caching, right? Or like our 5810 versus our back-end devices, such as our P5336, very high capacity, 61.44 terabyte. You need kind of a wide array like this to satisfy the requirements to really drive what we've been talking about is that TCO, right? So you're getting as most efficiency as possible, right? The other thing that Solidigm is doing is we're really cognitive of the changing in the speeds and bandwidths, right? Not only the workloads, but as we transition from PCIe Gen 5 into Gen 6, we have to think about form factors and the use cases there, right? Whether it's E1.L, E3S, E1.S, right? Solidigm is looking to substantiate those and create those form factors, and we're already doing it now to prepare ourselves for Gen 6 because the legacy U.2, et cetera, are not M.2 are not going to cut it as we continuously move forward, right? And we have that need for speed. We're also thinking too about the power efficiencies, right? We can't let that get away, right? Because power is going to be more of a mandate, right? When you think about AI holistically too, and you think about, and Sam touched upon it here about talking about the amount of power that's going to be consumed, what's relegated left within the system for storage, right? So you want to have an efficient, high density SSD product. So we're looking to how best we can manage that power, whether it's just operating or even in an idle mode, right? We're trying to get as much savings as we can, right? And then lastly, I would say is that we're really cognitive, and I think we kind of touched upon it here, is the need for storage, is the need also for high density, especially high density per watt. And that drives this performance model and this TCO model that we're wanting to deliver to CSPs who then can deliver that to their customers. So while we offer our 61.44 terabyte product now, look in the very near future for us to expand that and go further. We're not stopping, but we want to keep it in that relatively, the same form factor as much as we can to have that extremely high density. So there's a lot of different things that we're doing to kind of optimize to the best of our ability.
Yeah, and I think that to me is really the key for CSPs is they're looking for this innovation. They tend to be at the front edge of things from a efficiency, performance, density, scalability, all of these abilities perspective, and they're leaning into the newer technologies because, hey, if it can give them an advantage and help them differentiate, give more performance, throughput, denser, more efficient, more sustainable in many cases, they're really looking for it. But I want to thank you all for coming on board. This has been, I think, really exciting, and I think the CSPs that have been watching will get a lot out of this. And you know, I'm sure they're going to have a lot more questions for you about how they can use their products to really drive efficiencies and revenue. So thanks for coming on board.
Thank you.
Thank
Appreciate
you
it.
for having us.
Thanks for having us.
Also note, up next is our session on scaling up or scaling out, making the right storage architecture decision, which will be on August 22nd at 10 a.m. Pacific. Thank you for watching this episode of Hyperscale AI, Secure Data Services for CSPs. Stay tuned for the next episode.